This is an overview of Data Services Manager version 2.0. Let's start by looking at why there is a need for database as a service. App developers are working with automated pipelines. They need infrastructure supporting applications and data services to be only an API call away. The process needs to be frictionless. Today, they are often opening help tickets and waiting for data teams to become available to deploy their service. If the services cannot be delivered on time, developers might stand up their own environment or begin looking to public cloud options that introduce cost and governance concerns. The data teams are often consumed by a combination of repetitive tasks dealing with backup, patching, security, compliance, and even resource management. They balance that with ensuring availability and performance of production data services. They often have little time to provision new services, let alone do it in the developer's timeline. The infrastructure teams struggle to make available the required resources while ensuring compliance and controlling costs. Lack of visibility to bespoke data service deployments also factors into the problem. Data Services Manager provides a modern database as a service that is part of the VCF platform. Admins enable on-demand data service provisioning, but retain control through policy managed from within vCenter. The data teams benefit from automation of repetitive tasks. Things like backups, sizing, and upgrades are defined with service deployment and can happen automatically. Application teams have a range of pre-selected data services and versions that they can choose from as they automate the lifecycle of the services they need. Application teams have jumped on the Kubernetes bandwagon for infrastructure and application lifecycle orchestration. Data Services Manager 2.0 provides a Kubernetes API that enables self-service through a familiar ecosystem of tools. Teams that have embraced ARIA automation will be able to continue using that for self-service data services. Application developers provision databases programmatically with the specifications and policies they need. They can integrate database observability with their application observability. They can even be in control of their database configuration, things like choosing the number of replicas or picking the right HA and protection policy according to the lifecycle of the apps. Data teams can take advantage of Kubernetes-style declarative data service specifications. This means that configuration changes are simply a change to the specification and are applied through a Kubernetes-style desired state reconciliation process. Desired state also applies to outages. Failed services can be self-healing as the control plane continually reconciles the active state of the system against the original specification. DSM is a single control plane that unifies access and control of data services for the data and infrastructure teams. Data teams become more productive through the simplification of deployment and management of databases. They define and certify data service templates, define backup and DR policies for different use cases, and have a single view for monitoring and remediation. The infrastructure admin has visibility directly through vCenter in creating policies that will be applied to self-service activities of the data team. At the same time, DSM facilitates the dependency on virtual infrastructure owners who can have visibility into the data team's needs and perform tasks such as resource management, HA, and the setup of backup locations. Or they can delegate some of these activities to the data teams based on their company best practices. DSM 2.0 is initially available with MySQL and PostgreSQL databases. Google's AlloyDB Omni is in tech preview. Let's look at the architecture from a high level. Infrastructure admins enable a plugin within vCenter that deploys the DSM appliance VM. The DSM appliance provides a UI and Kubernetes APIs that are the interfaces for the database as a service. Admins create infrastructure policies with vCenter and assign them to DSM users. These policies define things like where the data services can be placed and what resources they consume. DSM users then submit a specification that defines the data service they want to deploy through either the UI or the Kubernetes API. This specification includes things like what database to deploy, the number of replicas, the CPU and memory and storage for the VM, backup policy, and maintenance window for the database, as well as any advanced database configuration options they may want to add. The deployment process creates one or more VMs, depending on the number of replicas desired, and creates Kubernetes clusters using a cluster API deployment process. The databases run as pods on the Kubernetes clusters. Let's look at the services we will support in the initial 2.0 version of Data Services Manager. Industry analysts and our customers have identified a clear trend toward open source database engines. DSM's initial focus is on the most popular of those engines. Additional data services are in our development pipeline. DSM will support PostgreSQL version 12 and up. The data service configuration allows application teams to add the advanced configuration as part of the specification. DSM will also support MySQL version 8. AlloyDB Omni is the downloadable and deployable on-premises version of Google's cloud-based AlloyDB. Its capabilities include improved performance for transactional workloads and analytic queries. A columnar engine and an embedded plugin enable generative AI applications using vectors from within the database. This is in tech preview for the initial release of DSM 2.0. Let's look a little deeper at VI admin governance and control. We mentioned infrastructure policies earlier. This is an envelope that the admin can attach resources to. The policies are created in vCenter and then can be assigned to DSM users or groups to define how and where they consume those resources. They provide granular control across compute, storage, and networking. Compute resources determine the vSphere clusters or resource pools that DRS will use for VM placement. Storage policies define the data stores available to this user. For instance, admins may choose high latency storage for early stage development and enable storage with higher performance and availability as workloads get close to production. Admins also define the networks and IP pools for the policy. The VM classes define the sizing for the individual VMs that will be deployed to run the database pods. Let's jump into vCenter and look at infrastructure policies. First, notice the DSM plugin has enabled some configuration options. Here's a list of policies. As we drill in, we see a list of configurable elements. Compute resources defines the cluster or resource pool for VM placement. Storage policies define the data stores and available free space. Port groups and the virtual switch are assigned here. Admins choose available IP ranges and assign them to pools. VMs configured as part of database deployments will get IPs from this pool. Folders for grouping the database VMs can also be assigned. And finally, VM classes, which define the CPU and memory for the database VMs, are added. We will now create a new infrastructure policy. First, we give it a name and a description. We choose the vSphere clusters and resource pools that database VMs can be placed into. It's important to choose storage policies that align with the compute resources you just chose. Each compute resource you chose will display here, and you must choose a compatible port group. And select a compatible IP pool or create a new one. Select the VM folder and then assign the VM classes. Keep in mind, this is how you would limit the size of the database VMs. Verify your choices and click Create. The DSM Provider Appliance delivers a centralized view for data teams and VI admins. The view is tailored to the role the user is assigned. Non-admin users have access to the database operations, but not system management capabilities available to administrators. The appliance can also be integrated to your preferred LDAP provider. Let's look at this from the view of the database administrator. The data and infrastructure teams can monitor both resources and inventory through the DSM UI. With the inventory overview, it's easy to see the set of data services deployed along with things like status, version, and various resource policies. Drilling into the details shows a consumption view. Overall CPU, memory, and storage consumed by the various data services. As the data or application teams deploy databases, they are subject to the infrastructure policies defined by the VI admin. The deployment wizard provides easy specification of data service configuration based on the policies that have been assigned. Let's put this all together. There are 4 steps to creating the specification. The first is the basic information like name, type of database, version, number of replicas, and access credentials. The second step involves choosing the infrastructure and storage policy, as well as the amount of CPU, memory, and storage available to the data service. The third step is choosing the backup policy and maintenance window. We will talk a little more about that on the next slide. Finally, any advanced database configuration options are added. As we said before, backups and maintenance are part of the specification and now automated. Admins will have defined one or more S3 compatible object stores as backup locations. User chooses a backup location, then the default backup schedule, or a custom schedule. She can also establish a maintenance window for the backups to be done. Many database patches will also be applied automatically in this window. We are going to log in to the DSM appliance and create a PostgreSQL database. Users can be assigned directly or through your LDAP provider. Infrastructure policies created in vCenter show up here. This is a dashboard with running databases. Let's create a new one. We will choose Postgres and version 14. Next, name the instance. You can choose the number of replicas. Multiple replicas creates multiple VMs. We will choose a single server, which combines the database and monitor into a single VM. Choose the infrastructure policy we created earlier, as well as the vSAN default storage policy, and a medium VM class. Let's give the database 120 gigabytes of storage. We are going to define the backup. VI admin has provided S3 compatible backup locations. You can use the default backup schedule or customize your own. Next, define the maintenance window to be used for automated patching. If there are specific database configuration options you want to enable, you do that here. After one final check of your configuration, click Create. The Create is in progress. Let's check vCenter. We go to the recent tasks and see that the virtual machine clone process is underway. Our virtual machine is running and has an IP address from the IP pool in our infrastructure policy. Back in Data Services Manager Provider Appliance, we look at recent operations and see the Create Database cluster is now complete. And one final view of our database configuration. Let's look a little deeper into some of the Day 2 operations. An essential aspect of managing data services is to be able to apply updates and patches as they become available. As an example, PostgreSQL might release a critical security patch. DSM provides a notification mechanism and a remediation mechanism to apply patches across a fleet of databases. If it is a minor version, the patch will be applied to the databases during the next maintenance slot. DSM provides insights across the whole fleet of databases, including which ones are impacted by the new update. Our customers have generally told us that they will take care of major number updates manually or by use of other tooling. They wish to control this aspect of lifecycle management. The DSM dashboard has an alerting window that provides visibility into any issues with the product. Any issue with the database provides a suggestion on how to resolve it, in a similar way to how vSAN Health Check uses the Ask VMware feature to direct customers to appropriate VMware KB articles, depending on the issue. There are also a considerable number of metrics, not just related to the infrastructure, but also the database itself. And last but not least, DSM has webhooks, which can trigger notifications via email, Slack, or other services like ServiceNow. Let's look at ARIA integration. ARIA Operations provides a unified operations management platform for your infrastructure and applications. You can extend the operations management through the addition of specific management packs for PostgreSQL and MySQL. These packs bring depth and context to the data that is available for your deployed databases and is easy to set up. You now have performance data and predictive analytics and real-time information about infrastructure issues that are impacting your data services. Both your provider appliance and data services can use ARIA Operations for Logs as a destination for log shipping. The DSM appliance contains a log inside agent to enable that log shipping. The deployed data services also contain FluentBit, which facilitates collecting, processing, and shipping logs directly to ARIA Operations for Logs. You can then nicely visualize and search on the log information. While DSM allows you to provision databases, you will probably want to use some automation and self-service capabilities to bring all of your application stack together. ARIA Automation very easily plugs into DSM. ARIA Automation integrates with all DSM workflows from day 0 through to day 2, and you can pick and choose which options to expose to the consumers of the service. Using ARIA Automation Orchestrator Agent and DSM APIs, you can integrate databases as custom resources usable with template as code deployments. In VMware ARIA Automation Assembler design, custom resources from Orchestrator are added as templates and the fields are pre-filled or prompted from the user. A completed template is shipped back to Orchestrator, which in turn sends it to DSM for action. The DSM custom resource can also be integrated with other custom resources to deploy the complete application. Deploying the data service could be made very simple, with all of the inputs coming from the template itself. Application as a service could be much more complex, including VMs, load balancers, etc. Orchestrator workflows can be combined for task tracking and integration with other resources. If you provide database as a service or application as a service, you can fine-tune which options to allow end users to tune, and which are hidden away and controlled by the admin. As an example, backups might always be enabled and not configured by the user. You might want to have different template definitions. For example, your test and dev teams might want a simple database deployment, while your IT team may want a full application deployment, which also includes a database as part of the stack. ARIA Automation also includes a service broker portal. This is a portal which allows all of the self-service users to request deployments of certain data services. Catalog items can be exposed or restricted to different users or teams of users. These catalog items in the service broker are built on templates, where you define which fields are given to the end users to populate. These populated templates are sent to the custom resource in ARIA Orchestrator, and the custom resource is sent to DSM where it is reconciled. Let's look some more at application user consumption. We saw this graphic earlier. The important point is that the consumption surface is a Kubernetes API, and application teams can use the ecosystem of Kubernetes tooling to interact with it, whether that is kubectl CLI, or through their preferred programming language, or simply through the UI. This is not just about deployment either. Data service scale up or out, as well as restoring from backup, or other service modifications can all be initiated in this way. The user submits a specification for the data service they want. This creates a custom resource within the Kubernetes cluster running in the provider appliance. There are operators in that cluster that use the cluster API implementation for vSphere to create the VMs and deploy the databases. Let's look at how this might work using the kubectl CLI. A user might create their cluster by submitting a specification like the one partially described in the cluster.yaml file. A modification like scaling out simply requires an edit of the custom resource that was created in the Kubernetes cluster to increase the number of replicas. Reconciliation happens automatically and would cause a scale out in the cluster. Let's see how a user can scale the number of replicas using kubectl. We have a cluster with a single replica, primary database and monitor in the same node. From vCenter, we see a single VM. We get the custom resource that was created in Kubernetes when the original database specification was applied. And then we are going to edit it. We simply change the number of instances from 1 to 3. Saving that change causes the desired state reconciliation to begin. And we see that it's in progress. As we continue to watch, you see the custom resources for the new replicas being created. This involves separating the monitor from the primary database and creating the replica instances. We jump ahead to see that the database is ready. Back in DSM, we verify the 3 instances. We see they are made up of a primary, a monitor, and a replica instance. And finally, back in vCenter, we verify that each of these instances is running in its own virtual machine. So in summary, application teams get self-service and can use their preferred way of deploying data services while getting automated backups and patching. Infrastructure admins retain control through policy-based enablement. Repetitive tasks are reduced for the data teams while they maintain visibility. Data Service Manager 2.0 provides the frictionless database as a service experience that application teams require while still ensuring that infrastructure teams have governance and control.